f prime, the definition of f prime? Anyone else? Please. Anyone? Anyone?
Would that be 1 over x plus h squared minus 4?
Yes. Minus 1 over x squared,
Yep.
minus 4, everything divided by h. Perfect. Good. We are looking for the least common denominator, like always in these situations. No matter how long the fraction line, most probably I will run out of room. You already know that. We need the least common denominator. Can anyone identify the least common denominator?
Would that be x plus h squared minus 4 and x squared minus h?
Yes, it has to be the product of the two, so it's x squared minus 4 and x plus h squared minus 4. Perfect. Now, obviously, you're going to say x squared minus 4, and here you're going to say the other one, but I'm going to expand it. I'm going to expand x squared plus 2xh plus h squared minus 4. Oh, look at that. I may be able to fit it in one row. So it's just 1, so this is x squared minus 4. Careful, now we are distributing -1 to all these 4 terms. Minus x squared minus 2xh, or negative h squared, and plus 4. What has to happen now? If it doesn't, then we know something is wrong. What has to happen? Anyone, please? Because if it doesn't happen, then I have to go back from the beginning.
The cancel the like terms like x squared minus x squared.
So all terms without h must go away. If they do not go away, then something is terribly wrong.
-4 and 4 goes.
And then x squared with negative x squared. Awesome. Good. So now we have limit as h approaches 0. These are the remaining terms. What do I have to do with those?
Factor out the h.
Yes. If I don't factor out the h, then I will not be able to complete. Since they're both negative, I'm going to factor out negative h. So then what is left? In parentheses. Two terms. I have to have two terms here.
2x minus h.
Yes, but plus, remember, because negative h times 2x is negative 2xh, and negative h times positive h is negative h squared.
Right.
So now that's the second thing that has to happen. Now at this point, I will apply the limit operator. I'm just going to write it one more time, so there is no ambiguity here. Now let's apply the limit operator. Because I applied the limit operator, it disappeared. Yes, ready.
Would it be negative 2x over x squared minus 4 squared?
That's it.
And x squared minus 4 squared, yeah.
Yep. So H disappears, so I only have negative 2x. H disappears, and I have x squared minus 4. X squared minus 4 times x squared minus 4 is x squared minus 4 squared. Awesome. Perfect. So now we have the other function, the last one here, which is 1 over the square root of 1 plus x. This is the least friendly one. Okay, we start with the definition of the derivative. I am on page 7. Okay, again, can anyone give us a definition of the derivative? Or specifically for this function, that's fine too. And remember, the derivative is not the difference quotient. It is not. How do I start?
The limit as h approaches 0.
You're going to dream about this. If I call you at 3 o'clock in the morning, you'll give me, no, I will not call you at 3 o'clock in the morning, I promise. But if I were to, you would give me the definition in your dreams, in your sleep. So what do I have to write?
F of x plus h.
Yes.
Map f of x over h.
Yes. F of x plus h minus f of x divided by h. And now, can anyone plug in x plus h here and give us the next step?
It would be 1 over square root of 1 plus x plus h minus 1 over square root of 1 plus x over h.
Very good. Everything over h. Good. Like before, we need the least common denominator. Not a nice problem, but we have to look at something like this. The limit as h approaches 0, I have to find the LCD. What is the LCD?
Square root of 1 plus
Say it again.
the square root of 1 plus x plus h times the square root of 1 plus
Yes,
x.
it has to be forever the product. So here's the not so friendly part, because now I have to multiply by a square root. Luckily, I only have 1 in the numerator, so this times 1, the square root of 1 plus x. This times 1. Okay. I will rewrite by flipping h. And then I have the square root of 1 plus x times the square root of 1 plus x plus h. And now this is the numerator. What do we need to do in this situation?
Rationalize.
Yes. So I need to multiply by the same quantity top and bottom because I need this to be 1. What will that quantity be?
Square root of 1 plus x plus square root of 1 plus x plus h.
Thank you very much. And they have to be the same. If they are not the same, we changed the problem. That's why they have to be the same. Now the denominator is awful. 1, 2, 3, 4 factors. H, the square root of 1 plus x, the square root of 1 plus x plus h times this, in parentheses, the square root of 1 plus x plus the square root of 1 plus x plus h. Now I have to be very careful with the numerator. Can anyone give us the numerator, which means this multiplied by this It's better to put parentheses and then distribute and not do it at once. It's up to you. I'll write what you tell me to write.
It'd be parentheses 1 plus x.
Yes, 1 plus x, it's okay. It doesn't need parentheses. It's okay. But then we have to write minus
1 minus x minus h.
Yes.
Parentheses. Those.
Yes, let's write parentheses for everyone to see. But yes, you are correct. You don't have to write parentheses. You can distribute already. Awesome. Now I have to be careful. I have to distribute. And remember, all terms without h must go away. Do not drop the limit operator. We are not there yet. So 1 plus x minus 1 minus x minus h. Over this, I have to write it again. The square root of 1 plus x, the square root of 1 plus x plus h, and the square root of 1 plus x plus the square root of 1 plus x plus h. That's why I was saying this is not a friendly function, but it's fine. We had to look at something like this. What has to happen next? If it doesn't, I'll say, oops, something is wrong.
Positive 1 minus 1 cancels.
Good. All terms without h must go away. Good.
And x cancels.
So let's write it one more time. Negative h at the top. H, the square root of 1 plus x, square root of 1 plus x plus h, and the square root of 1 plus x plus the square root of 1 plus x plus h. Now the second thing that has to happen, otherwise we are in trouble, is yes, simplify. So normally when we simplify factors, we say simplify. When we cancel like this. Okay, good. So now we can apply the limit operator, and it goes away because we're applying it. Can anyone give us the final form? Negative 1.
Oh, I dropped the negative one. Negative 1 over 1 plus x squared.
Careful. It's the square root.
Square root.
1 plus x. Because the square root of 1 plus x plus the square root times the square root of 1 plus x is 1 plus x. And now let's see what we have left from here. What is left from that?
1 plus x.
Yes, plus 1 plus x. An apple plus an apple. How much is an apple plus an apple?
2.
2. So the square root of 1 plus x plus the square root of 1 plus x is 2 the square root of 1 plus x. 2 the square root of 1 plus x. This is the derivative of that not friendly function that we picked. How are we feeling now? Is this better?
It's too much.
I know, but not for you. You answered all my questions. Okay, so we can always go back. We're also going to review for the test on Wednesday. So you can, if you find anything else, that's why I insist that you finish all WebAssign by Wednesday. So because if you finish it by Wednesday and you have questions, we'll do them in class. If you don't, you're on your own. So that is absolutely crucial. Okay, so that's my page 9. So here for this question, if you would like to look, I chose this, but we can choose another, but I already I printed it out, and since I can't get into the book, if you want to choose something else, we can. So Amanda, if you want to share page 162, so if you want to go back one. Again, you're a lifesaver. Thank you so much. So if you want to go back one page to page 162 and look at problems, problem 3, for example. I chose D. So in problem 3, I chose D, but if we can, I don't mind if we change it to something else. So we are given a function and we're asked to graph a rough estimate. It's not going to be an exact graph, but a rough estimate of the derivative of this function. Sometimes we may be given the derivative when we may be asked to find the function. But this is a function, and we're asked to find its derivative, to graph its derivative. Is this okay? Do you want to choose something else? Is this okay with everyone? Okay, so this is a function f of x. And right exactly underneath it, I am going to graph an estimate. So this is f of x, an estimate of f prime. But how do I do this? Well, let's think for a moment what the derivative means. Let me stop